I'm Cami Kronbauer, and we are going to be doing a lesson today on functions. And actually, the next few lessons we'll be doing will be dealing with functions. To start out, though, we are going to watch a video.
My prices are low, and I work with great speed, and my work is 100% guaranteed. By my new patent process of polar potoxis of the inner subnuclear noosebomb nogoxis, you'll get a star like the star-bellied sneetch for the mere paltry payment of $3 each.
A star? Here?
Yes, my friend, there. And the first to go through gets the trip at half fare. Thank you, thank you, thank you.
It works! Yeah! It works! It works!
Okay, so that video, some of you might recognize from a Dr. Seuss cartoon called Sneetches, but it's a great example to start us off for what functions are. And I'm going to start off by drawing us a little picture, and I want to also give a little quick bit of information here. During this next few lessons, I really would like you to concentrate on taking good notes. 3 reasons. Number 1, by taking notes, physically moving your hand to do it, you're going to remember things better. Number 2, it's a skill that you can use in any classroom, anywhere, and when you get to college, it's a skill that you're really going to need to depend on. Number 3, it's going to be helpful to you because you are going to be using this as a reference to look back to as you're doing your homework. So, as we go through these, I will be taking notes on my page. If I write it down, I really hope that you would write it down and work on organizing your thinking. Okay, so back to functions and back to the Sneetches. Not much of an artist, but I'm going to attempt to give us a machine. I'm going to call it our function machine. Dr. Seuss style. And the Sneetches, we're going in. And we're going to, rather than Sneetches going into the machine, we're going to be putting numbers into our machine. And we're going to do something to those numbers, and they're going to come out of our machine. Now, as we go through the course of talking about functions, we're going to have a few different machines. So I'm going to name this machine F. And up here, the things that are going in, our input, our numbers that are going in, I will probably be referring to them as the domain. The numbers that are coming out, or our output, I will be referring to those as the range. Now, a couple of things have to happen. First of all, I've got to set up my machine, just like the Sneetches had to have a machine that puts stars on. We're going to set up our machine to do certain things to our numbers. And I'm going to call that, we're going to set up the rule for our machine. And our rule for this particular machine is listed as x plus 1. What that means is when I put a number into my machine, it's going to go in place of the x, wherever the variable is at, apply the rule, and then the new number will come out. So, for example, if I put a 2, the number 2, into my machine, the 2 is going to run in through the machine. It's going to plop right here in place of the x. 2 plus 1 gives me a 3, so the 3 comes out. Let's take a few other numbers. Let's try it. A negative 1. As a negative 1 comes into the machine, negative 1 plus 1, 0 comes out. And let's do one more. Let's try a half. When I put a 1/2 into my machine, 1.5 comes out. Now, this is kind of a picture of what's going on, but there are lots of different representations for functions. And those representations of functions are things that we are going to be introducing today and then taking a more detailed look at as we go through the next few lessons. So, if we look at our example here, sometimes you're going to see a slightly different picture. Oftentimes, textbooks will show a picture where all they're showing you are the numbers that are in the domain and numbers that are in the range. And what they'll do is we had a 2, a negative 1, and a 1/2. The numbers that came out, no particular order here, were 0, 1.5, and 3. But to show how they paired up, when the 2 went in, the 3 came out. They'll show little arrows to show what numbers are paired with what other numbers. When the negative 1 went in, the 0 came out, the half went in, 1.5 came out. So we get a picture form or representation of the function. Sometimes you'll see this as a table, representation of functions in a table form. Quite often we'll just have a list of, you're fairly familiar with this kind of a table. When the negative 1 went in, the 0 came out, 2 gave us a 3, and a 1/2 gave us a 1.5. Sometimes you'll see a different form, a list of ordered pairs. In this representation, we're going to list it as a set showing what pairs or what numbers were paired together. The negative 1 was paired with the 0. The 2 was paired with the 3. And the 1/2 was paired with the 1.5. Okay, so we have a representation of a function this way. Based on our ordered pairs, we can represent a function as a graph. So we can put these ordered pairs onto a graph with x, y coordinates. And we can graph these points, negative 1, 0, 2, 3, and 1/2, 1.5. And so we have our points represented here. I could draw the line through them And our line would represent our function. Another way we represent functions is algebraically. And when we use algebra to represent functions, we are going to use function notation. And function notation basically is going to give us some symbols to show us what was going on our function machine. If you remember back to our function machine that we drew, the name of this particular machine was f. So when we list in our function notation in algebra, what we're doing is we're going to list the name of our function first, and then we're showing, and let's go ahead and, this is the name of our machine. And then what we'll be doing is we are going to show where the numbers are going to go in, what variable we're using. If we could look back at our machine, the numbers were going in place of the x. So we're going to show that with this x. We'll label him. This is where the numbers are inserted into our machine. And then in function notation, what we do is we list our rule. And the rule that we had for our particular machine was x plus 1. So in function notation, what we're doing is we're going to be listing all of these three pieces. The name of our machine, the variable we're using, where the numbers are getting inserted, and then we're going to tell everybody our rule. Now, when we put in, for example, the number 2 into our machine, we can use our function notation to show that we replaced the x with the 2. What we were doing is we were putting the 2 into that position. So we can show that we're taking the 2, putting it in there, and that we would say f of 2 equals 3. Or in other words, 2 gets paired with 3. Okay, so now that you have seen some of the different representations of functions, I'm going to give you a more formal definition of a function. And the more formal definition of a function, and let's go ahead and write this out, is we're going to go through and talk about a function being a rule of correlation that assigns each element in set A to exactly one element